Hello student, welcome to Naushala. In periodic classification of element, the most important concept there, Mendeleev's periodic table. Student, what is Mendeleev's periodic law? Write its merit, write its demerit. Such type of many questions are coming on Mendeleev's periodic table in your board examination. So very important concept there today's. Instead of talking here then let's start the lesson. In this topic, first thing you have to understand children, in Mendeleev's periodic table, how many elements are there? So number you have to remember here, total 63 elements are there in Mendeleev's periodic table. Because this number is very important. Same number there for Newland also. In Newland's table there were 56 elements and here 63 there. Clear? Second, when Mendeleev arranged the elements in increasing order, he considered atomic mass as a main property. So you can say that the whole table's arrangement is based on atomic mass, and as per the atomic mass, in increasing order he kept all elements in this table. Increasing order means hydrogen's atomic mass 1 there, so first will come, then lithium, beryllium 9 there, boron 10 there, carbon 12 there. In this way, in increasing order, he arranged the 63 elements. Children, when he arranged the elements, then he found that properties of elements are there, no? It repeat after certain interval. For example, see, lithium's property, which type there? After a certain interval, when it comes to sodium, sodium's property somewhat repeated like lithium. So he is telling that properties of elements are there, no? It repeat after a certain interval. And related to that only he gave one law called as Mendeleev's periodic law. What law saying? Properties of elements are periodic function of their atomic masses. Periodic function means property which repeats after certain period. Are you getting? So properties of elements are periodic function of their atomic masses. So as the atomic mass is changing, their property will repeat after some. So this law is called as Mendeleev's periodic law. So here 3 questions they will ask. 1. How many elements were known at the time of Mendeleev's table? 63. Table's arrangement in what way they are made? So you have to remember that whole table is based on atomic mass and elements are arranged in an increasing order of their atomic masses. Clear? And very important law there. What is law statement? Law states that properties of elements are periodic function, means which repeats. So periodic functions of their atomic masses. Clear? Now student, when we talk about Mendeleev's periodic table, few basic concepts regarding table understand. This is Mendeleev's periodic table. If you see your numbers are there, 1, 2, 3 like that. So there are total 8 number you will find till the end. These are actually columns are there in the table. So such vertical column 1, 2, 3, 4 like that. These vertical columns which are present in table, these vertical columns in Mendeleev's periodic table we called as a group. So one important concept here you have to remember that what is group? Definition they can ask. So what is group? Groups are the vertical column in a Mendeleev's periodic table. Second, sir, total how many columns means how many groups are there? 8 are there in this table. Second, if you see here also like your notebook lines are there, in that way also you will find like this thing 1, 2, 3, 4, 5, 6 in this way. So these are called as a periods. Period what there? Horizontal row there. Horizontal row in a periodic table. Like that we are having total 6. What is 6? 6 are the horizontal rows are there. So horizontal row in a periodic table, it is called as a period. So 3 things are there here. 1. What is group? Groups are the vertical columns. Vertical columns in a periodic table is called as group. Total groups are 8. Second, horizontal rows in a periodic table is called as period. These periods are 6 there. So vertical columns are called group. Horizontal rows are called period. Total number of group are 8. Total number of periods are 6 in Mendeleev's periodic table. Clear? Simple. Now student, one more important thing you have to understand regarding Mendeleev's periodic table, because of which he became so famous, it's merit. Merit means what is a good thing about the Mendeleev's periodic table. Are you getting or no? Something good that therefore there in syllabus? Understand. Come here. When he started to arrange the elements in this table, no, he was arranging like this. He kept lithium first, then boron, then beryllium. Why, sir? Increasing order of atomic mass. So increasing order, if you see 6.94 there, 10.81 there, 14.09 there. So obviously it is increasing order there. But when he kept in increasing order, he thought that beryllium's this place is not right here. Because beryllium's property is not matching in this place. After boron, he kept beryllium because beryllium 14.09 atomic mass there. But he was not happy with that. He thought beryllium which there, beryllium will not come in this place. So now what to do? He decided to check the atomic mass of beryllium. He revised the atomic mass. Revised means understanding. He rechecked that. Again checked what is exact beryllium's atomic mass. Then surprisingly he found that beryllium's which actually 14.09 atomic mass was there already. It is not there only. Actually its mass is 9.4 there. So earlier how many scientists used these all values? They used all wrong values. No one thought that. We will check it. Merits, therefore merit. Mendeleev, why great? Because of such things. So once he placed the element, then doubt came to his mind that this will not come here. Because its property not matching here. So he revised the atomic mass, rechecked the atomic mass, then found that 14.09 which already it was there, it's wrong there. Correct value is 9.4 there. Then now 9.4 there, boron 10 there. So before boron, beryllium place will come. Check here. It was after boron. Now it is before boron. Now place also right there, property also matching. So the first merit which there of Mendeleev is related to this. What? Some atomic masses he revised. Some elements atomic masses is revised, rechecked to give them proper place according to their properties. To give them place, correct place as per their properties, he revised their atomic masses. Example, beryllium. Earlier 14.09, after the revision, after rechecking, 9.4 came. Clear? Very nice work he did regarding this. Now second situation. Second is very important that when he made table, no, while writing table, middle he was keeping some vacant places like this. Empty box he was keeping. Vacant place means empty place he kept in the table. Now sir, if vacant place keeping, then what's special there? Like that fill in the blanks also empty only we are keeping many times. Only vacant places he not kept in table. At that place which element will be discovered later on, that element's property also he predicted. Means you 2 minutes carefully understand here. He kept the place for those elements which are yet to be discovered. Elements which are not discovered. After few years, obviously it will be discovered. So for them, first only he kept some place here. Not only this, at this place, which element will come? What will be their properties? Whether it will be metal, non-metal, it will react with oxygen or no. Such all property first only he wrote. He predicted their properties. Seeing how great work is there, in table 63 elements already there. Plus he kept some vacant places for those elements which are yet to be discovered. So, not only the box, add that vacant place, which element will be discovered. What will be its property? First only he gave. And surprising what there, whatever property he predicted, all matched with discovered elements. That is a great thing there. Getting? One more thing you remember here. When he kept box, to this box also he gave some name. Ica boron, Ica aluminum, Ica silicon, like that. Eka word comes from Sanskrit. Eka means 1. So after calcium 1. Getting? After boron, 1 more box. After aluminium, 1 more box. Like that. Next box. So that word represented in Sanskrit as a Eka means ek. So 1 place next to the known elements. So these were known. After that 1 box, places are there. So Eka boron, Eka aluminium, Eka silicon. These elements name gave by Mendeleev before discovery. After discovery, what are their name? In paper they will ask. Eka boron, before discovery name there. After discovery its name is scandium. Eka aluminium name there gallium. Eka silicon's name there germanium. So for match the pair, MCQ, true or false, your objective type of question, this table is very, very important there for you. You have to learn this. Clear? So what things to remember here? Mendeleev kept some vacant places in table for those elements which were not discovered. Okay, sir. He also predicted the properties of these unknown elements. Which unknown elements name he gave? Eka boron, Eka aluminium, Eka silicon. After discovery, their name will scandium, gallium and germanium according to the table. Interesting what the properties of those elements he predicted matched correctly, means almost all properties came correct. Clear? Now only one thing children here remember, while learning this table you will feel some difficulty, that confusion happening. To remove that confusion I will give one trick to you. Learn here. Bus standing at gate, slowly go. Bus standing at gate, slowly go. In this way you match. Boron, scandium, aluminium, gallium, silicon, germanium. Okay. So bus standing at gate, gallium there, silicon, germanium there. So in this way you can remember. Sir, but here also G there, here also G there, confusion not happening? No, see. Aluminium spelling, say aluminium, partner small there, gallium. Getting? Here germanium, partner silicon there. Both name big not there in this. Aluminium, germanium, partner not there, no? If big name there, partner will be small. So aluminium, partner gallium. Getting? If germanium, partner silicon. Getting? From that you will click only. So you just remember, bus standing at gate, slowly go. Bus standing at gate, slowly go. This will be your trick to learn which elements before and after discovery their names are there. Now let's talk about one very interesting merit about Mendeleev's periodic table. This is third there. Now children, when he made Mendeleev's periodic table, that time noble gases were not discovered only. Noble gases means which one? Helium, neon, argon. No, helium, neon, argon, krypton, xenon, radon. These elements we called as noble gases or inert gases. They are not taking part in any chemical reaction. Okay? If you don't know this, how to learn, means each group's name how to learn. For this one trick I gave, on same channel you will find one video regarding periodic table tricks. You can check out that, how to learn these names. Okay? Now see here. So when this table made, that time these gases were not discovered only. So obviously noble gases was not there in table. Now later on what happened, when these gases were discovered, now it's time to keep them in table. Getting? Now in table he kept vacant places, no doubt. But how it is, only place is not important. That element's property also should match here. Now these all inert gases are there, noble gases are there, non-reactive there, not taking part in any chemical reaction. So such element place you can't give here. So what he thought? We will do one thing. We will create one separate column, name as a 0 group. Already 1 to 8 there. He created one more group, named as a 0 group. And in that 0 group, he placed all noble gases without disturbing the earlier previous table. No disturbance in this. Just one extra column, extra group we have to make, name as a 0 group. Getting? So when Newland, you study Newlands, in that one problem was there. 56 boxes was there, all full. So there was no place to add new element. So from that Newland's drawback, he learned something special and he made tables arrangement like that anyone new one will come, we can adjust here. So important word there here, at the time of his table, there was no place for noble gases. Obviously no place. Why? Because they were not discovered only. Now, these noble gases, helium, neon, argon, when they discovered, we created one special group called as a zero group. That one. All noble gases we added in that. And when we placed that zero group in table, there was no disturbance to the original periodic table. Means inert gases, noble gases were placed in table without disturbing the old periodic table. So that much creative work Mendeleev did in the table. Are you getting? So we added also and there is no need to disturb also anything. Therefore special there. Total how many we discussed? Total 3 merits are there, children. First is he revised the atomic masses of some elements. So all 3 merits, I gave one only line to you. Just if you learn this now, you will recall all 3 merits. Okay, if merits asking, then 2 or 3 marks they will ask you. So revise the vacant places, welcome noble gases. Revise the vacant places, welcome the noble gases. This simple line there to remember the merits of Mendeleev's periodic table. How see? In revise the atomic mass means what, sir? Starting merit we discussed. Beryllium's first, how much atomic mass was there? 14.09, sir. Later on it became 9.4, sir. So this is called revising atomic masses. So some elements atomic masses are revised by Mendeleev to give them proper place. So this is your first merit there. Second, in table he kept some vacant places. In table he kept some empty places. Yes or no? So he kept vacant places for whom? Those elements yet to be discovered. This is my second merit there. Third what there? Third is when noble gases were discovered, he created a special zero group to keep that. So in table it was not there. Later on came like guest. So we did welcome to them. So it is welcome noble gases. Clear? So revised means revised the atomic masses. Vacant places for those elements which were not discovered. And when noble gases discovered, we placed in table by creating zero group without disturbing the remaining table. So these are the 3 important merits of Mendeleev's periodic table. Clear? Now see, children, no one is perfect like this we are telling. No? So here also some mistake made by Mendeleev. Some mistakes are blender there, but some are silly there. You can adjust it there. See here. Now, if you think about cobalt and nickel, cobalt's actual atomic mass is 58.9 there. Nickel's 58.6 there. So 58.9, 58.6 there. Now, Mendeleev, instead of taking in a point, he made it as a whole number. Means instead of taking 58.9, he considered it as a 59. 58.6 round figure means whole number. He considered as a 59. Means 58.9, 58.6, both masses in whole number, what is coming? 59, 59. Now you see, if both elements atomic masses 59, 59 there, then confusion will happen, no? Who will come first? Because both 59 there. You don't think that because he not consider, no? I am telling to you actual values are this. He not used this. He used both 59. So there was confusion regarding their sequence. Confusion why created? Because of whole number atomic mass. Getting or no? If same atomic masses are there, you think no like this in classroom. Suppose 2 students got same marks. Then how to decide whose rank first there, second there? Marks are same only. So teacher will tell that both you first will be ranked there. So like that we can't, your both atomic mass is same there. Okay, you both same place. Same place we can't keep. Separate we have to keep. Separate keeping, then first who will be there, second who will be there, you have to decide, no? How to decide? Both masses same will be there. So this is confusion happen in table. Simple it was. If point you are considering, this problem not coming, no? But don't know why he not considered point. He considered whole number. Get it? So the whole number atomic masses of cobalt and nickel, whole number atomic masses of cobalt and nickel, what there? Same there, 59, 59. Therefore, there was an ambiguity. Ambiguity means confusion it was. So confusion happened regarding sequence in the table. Obviously, you understand, confusion will happen only if both same there. Getting? So this is first mistake, first demerit of Mendeleev's periodic table. What it is? Whole number atomic masses of cobalt and nickel same there. Therefore, there was an ambiguity, confusion regarding sequence in the periodic table. Clear? Now understand, children, second very important. One word we are using in chemistry called as isotopes. Isotopes means, one example, see. If I am talking about oxygen, one oxygen atom's mass is 16 there, 16. One more oxygen we are having in nature whose mass is more than this there, that is 18 there. So here 8 plus 8, 16. Here 8 plus 10, 18 there. So what this 8 proton, 8 neutron. Knowing no, atomic mass means addition of proton and neutron. If you both addition doing, then atomic mass number will come. So 8 plus 8, 16, 8 plus 10, 18. Both oxygen. Breathing you are doing, you are taking both type of oxygen in your body. Oxygen 16 also going, oxygen 18 also going. Both type of oxygen you are taking now. Getting all of you? So, here important word there. Sir, if both type of oxygen I am taking, then to my body both okay only there. Yes. Why? Because their chemical property same only there. When I am breathing and I am using oxygen 16 also, 18 also, means to my body both okay there. Why okay there? Because both chemical properties same there. Getting? So oxygen 16, oxygen 18 are the isotope. And in isotope, chemical properties are same. So this both oxygens are there, both properties same there. Then okay, no sir. If both properties are same there, then keep both in same box. Here only keep oxygen 16, oxygen 18. But like this we can't keep, no. Because their atomic masses are different. 16, 18 how to keep? At one place we have to keep 16. One place we have to keep 18. Because you have Mendeleev's periodic table in increasing order there. Are you getting? So each box one element, then 16 will be first and 18 will be second. Both you can't keep in same. Why not? Because their atomic masses are different. So problem understanding. Both isotopes are having similar chemical properties. Are the chemical properties same there? Keep in one box. But other side their atomic masses are different. Then keep in two box. Like that confusion created here. Getting? So in Mendeleev's periodic table, there is no place for isotopes. Confusion there, no? How to keep? If chemical properties same there, like this thinking, then one box both will come. Atomic masses considering, in two box will come. Better than not to give place only this. Getting? So isotopes were not there initially. But when they discovered these isotopes are having, just one second, these isotopes are having same chemical properties but different atomic masses. That only I am telling. Both oxygen chemical properties same. Keep in one box. Not possible. Why sir? Atomic masses are different. So two places you have to give. Then it's very difficult to place them. difficult there, confusing there. So this is the second problem faced by Mendeleev. Now children, this when he arranged the elements, now many times I repeated that arrangement in an increasing order of atomic masses there. I made round figure, don't confuse, for simple understanding. Here actually 6.9 there, I am writing 7, so easy understanding will be. Okay. So lithium 7 there, beryllium 9 there, boron 11, 12, 14. When you go in increasing order, just check the difference in the both. So lithium 7 there, then it is increased by 2 here. Beryllium 9 atomic mass there, it is increased by 2 here. Boron 11 there, carbon 12 there, increased by 1. Carbon 12, nitrogen 14, increased by 2. What I want to say, when atomic mass is changing, increasing, rising, rise means to increase. So when atomic masses are rising, it will not rise in a similar manner, no? It is not uniform rise there. It's not like that. 2, 4, 6, 8, 10, 12, this is uniform there. Because every time change by 2, every time change by 2, like this there. This is called uniform. Here increase by 2, then 1, then 2, anyhow there. So children, if rise in atomic mass if it is not uniform, then we can't predict that between 7 to 20 how many elements will come. How to predict? It is impossible there because gap is not fixed, no? Anyhow increasing. Here see, if I remove 1 from this, if I remove this, and I am asking to you, children, tell me what will be here, one number will come. How many numbers will come between 4 and 8? What sir? So simple there. 2, 4, 8. One only number will come. 6 here. Why? Why so much? Surely you can tell. Because increase, rise uniform there. 2, 4, 6, 8, 10. Here not there, no? Therefore between 7 to 20 means this is one element there, this is second element there. Between this, how many elements will come? We can't tell. Because atomic mass increasing non-uniform. Same increase not there. Therefore this problem there. So when elements are arranged in an increasing order like this, the rise means increase in atomic mass does not appear to be uniform. Obviously it is not uniform. 2, 2, 1, 2, anyhow there. So it was not possible to predict how many elements could be discovered between two heavy elements. Read it. It is not possible. It was not possible to predict how many elements discovered between two. This is my first element there. This is second. How many elements will come between this? We can't predict. Why we can't predict? Because increase in atomic mass is not uniform. So uniformly not increasing, therefore we can't tell how many elements will come between two heavy elements. Now children, one more problem which Mendeleev faced, it was related to this small element hydrogen. Now hydrogen's what problem happens here? Hydrogen showing property with two group of elements. Here group 1 there. Group 1 we called as alkali metals. Group 1 elements are called alkali metals. It is a family name there. Group 7. Later on when we will discuss modern periodic table, no? In modern periodic table, 7 means 17 happening. Remember this. So group 7 is called as halogens. So first thing what you will learn, group 1 is also called alkali metal. Group 7 is called as halogens. Okay. Now problem understand. Hydrogen is having similarity. It is having some similarity with alkali metal also, halogens also. Means the property which hydrogen showing, it is showing by alkali metal also, halogen also. So where to keep? You remember the connecting link, one concept there in biology, science part part 2, first chapter, somewhat same there. See, so hydrogen where we should be placed there? It is very difficult there. Why, sir? Because hydrogen property alkali metal like that, then some will tell keep in group 1. Hydrogen property halogen like that, then some will say in group 7 you keep. So this will create problem. So there is no fixed place for hydrogen in Mendeleev's periodic table. Are you getting? Hydrogen's property similar there to alkali metal also and halogen. But sir, you are telling similar means what? See here. If I am having alkali metal as a sodium, Na is one alkali metal there. If this alkali metal reacts with chlorine, then I will get a final product sodium chloride NaCl. Getting? I am not doing balanced reaction, just to understand I am writing in simple. Na plus Cl, NaCl there. Okay? So formula how you got, see, NaCl. Now hydrogen, see, hydrogen. This hydrogen, if it is reacting with chlorine, then it will also make similar formula, HCl, H plus Cl, HCl. See the way of formula getting, same there. So we are telling hydrogen shows similarity with alkali metals. Now sir, what about halogen? See, hydrogen, it is present in nature in the form of H2. It is called diatomic, diatom. Two atoms together present in nature. So hydrogen, we are not writing hydrogen H. We always write H2 because it is diatomic there. So hydrogen is present in a H2 form. Halogen who are there? Fluorine, chlorine, bromine, iodine. They are also found in same way. F2, Cl2. If bromine there, then Br2. Iodine there, then I2C. So like halogen, hydrogen also exists as a diatomic molecule. Diatomic, understood? Diatomic means two atoms together in the molecule. So hydrogen H2, halogen also Cl2, Br2, I2. Similarity there. So that only I am telling that hydrogen shows similarity like group 1 alkali metal as well as group 7 halogen. So there was difficulty to place hydrogen in a Mendeleev's periodic table. All demerits, I am having one small trick for you. Whole number isotope raised the hydrogen problem. What it is, sir? Whole number isotope raised the hydrogen problem. See here. Whole number means the whole number atomic masses of cobalt and nickel created ambiguity, confusion regarding their sequence. First demerit there. That instead of considering the point, he considered the atomic mass of cobalt 59, nickel also 59. So which one will be the first in the table? That ambiguity, confusion happened because of whole number. So my first demerit, whole number there. Second, oxygen 16, oxygen 18, chlorine 35, chlorine 37. These are the isotopes. So isotopes are having similar chemical properties but different atomic masses. So their place also problem came. Second demerit. Third, increase in the atomic mass, rise in the atomic mass is not uniform. So we can't predict between two elements new how many elements will be discovered. So that is my raised. That is rise in the atomic mass is not uniform in table. This is my second one. Third one. Fourth one we discussed about hydrogen problem. What was the hydrogen problem? Hydrogen one side showing similarity with group 1 alkali metal. It is showing similarity with 7th group halogens. So hydrogen similarity there with alkali metal also halogen. So no fixed position is given to hydrogen in Mendeleev's periodic table. Clear everyone? So here important things were there. 4 demerits. First, whole number, isotope, rise in atomic mass and hydrogen problem. All demerits in single line. Whole number isotope raised the problem of hydrogen. Whole number isotope raised the hydrogen problem. Simple there. So by using this one line, you can recall all your demerits. So today we completed Mendeleev's periodic law, what are its 3 merits and what are its 4 demerits. Clear? If any doubt you are having regarding this, you can comment in the comment box. And if you like our videos, please subscribe the channel and share the link with your friend. Thank you.